Have you ever been ice skating? Think back to the first time you got on the ice. It was slippery, right? Really slippery. The ice makes it hard to stay still, but it makes it really easy to glide. Have you ever wondered why? Why can you glide on ice but not on the ground? Why is it so hard to stand still on ice? Those are all great questions. Today, we're going to learn about what lets you glide on ice but not on the floor. First, let's begin by thinking about what you need to skate. Ice skates, an ice rink, and well, you. When you step onto the rink, the blade of your skates will touch the ice. As two things touch, they rub against each other. Depending on the slipperiness of two things touching, the objects will rub against each other easily or more roughly. Since the ice is a slippery surface, you will slide when you touch it, even though your skates are not slippery themselves. Once you leave the ice rink, you have to walk on the regular floor with your skates. In this case, the floor is not a slippery surface, so you won't slide. Here, the floor is rough enough to keep you from sliding. The thing that determines how easily two objects rub together is called friction. Friction is a force that opposes an object's slide or attempted slide. Anytime two objects rub against each other, they cause friction. How much friction do you think is produced when you skate on ice? Not a lot, right? You know this because your skates glide easily. But let's go back to what happens when you get off the ice rink. The friction between your skates and the floor is big enough to prevent you from sliding. This is why it is easier to stand on regular ground than to stand on ice. When friction is bigger than an object's attempted slide, the object will not move. But when an object exerts enough force to overcome friction, then it can move. The friction is smaller on the ice, so you need to exert less force to move compared to the ground. Let's talk more about how friction works. Friction always acts in the direction opposite to an object's motion. Have you ever noticed how a soccer ball slows down after you kick it on a field? That's because of friction. Friction slows down an object in motion because it is always acting to oppose the object's slide. If we kick the ball on a smooth surface, like a tiled floor, with the same force, the ball will travel farther than on the field because there is less friction. So, we can conclude that the rougher the surface, the more quickly the object will slow down. From this example, we can also learn that you can change friction by changing the materials that are in contact with one another. Different surfaces produce different amounts of friction. Let's say we pushed a wood block with the same force over 3 different surfaces: ice, wood, and sandpaper. Over which surface will the block travel the farthest? If you guessed ice, you'd be right. Ice reduces friction, so the block will be able to travel more. On sandpaper, you'd have to apply more force than on the ice to get the block to move. We can observe friction every day. In fact, it actually helps you live your life. If there was no friction, you wouldn't be able to walk. People would slide around everywhere. Think about it. When you take a step, you push yourself forward with your foot because your foot can grip onto the ground due to the friction between the ground and your foot. But let's say someone spilled melted butter on the floor. You would probably slip because there would be almost no friction between your shoe and the floor. Can you think of other examples where friction may be useful? What about on the road? Cars on a road need friction to move because the tire needs to grip onto the road without slipping. This is why car tires are made of rubber. Rubber and concrete produce a lot of friction when rubbed together. In cases like this one where friction is helpful, it's called traction. What about instances where friction doesn't help? Like if a slide at a park doesn't have a smooth enough surface, you might get stuck going down. Or if you don't oil your bike chain, your bike may not work. These are all examples of friction when it is not helpful. Now that you know all about friction and how to observe it in your life, you probably want to test it out yourself. And you can experiment with friction at home, but you have to be careful. Testing out friction can be dangerous, so make sure you have a parent or guardian supervisor before trying anything out. One thing you can do is to test the friction between your feet and the floor. First, try to slide on the floor using shoes. Not so easy, is it? Now try to slide with socks. The socks produce less friction than your shoes because they're made of a smoother material, so you should be able to glide around your house. Thanks for listening, and I hope you're excited about friction.